Welcome back to the next lesson for the Marine Radio Operator Permit class by National Seafarers Academy. Here's the class agenda. Where we are right now, we've just completed the Global Maritime Distress and Safety Systems Subpart W lecture, and we're going to start the Subpart S, Sierra, the regulations for the small passenger vessels. Now this Subpart S I've actually broken into two different lectures. Why? Because I want you to view two movies that are appropriately placed in the middle of the overall Subpart S. First movie is going to be the VHF Radio and Digital Selective Calling Procedures movie, and the second one is going to be Emergency Radio Call movie. So again, those two movies are kind of appropriately placed in the middle of the Subpart S. So the Subpart S is broken into two different lectures. This is the first lecture for the Subpart S. As you can see, we're in the Subpart S, the small passenger vessel regulations. So the applicability of Subpart S. As you can see there by the chart, you're a small passenger vessel. You're carrying more than 6 paying passengers, so that means you're an inspected passenger vessel. And you're less than 100 gross registered tons. So those are all the vessels that we typically see in the dinner and tour vessel industry. That's the boats that we're operating with a 100-ton license or less. And the way you read this chart is you can see the first entry there, oceans less than or equal to 3 nautical miles. So if you're operating your vessel inland out to 3 nautical miles, you need a VHF radio capable of operating on channel 16, 6, and any other working frequency deemed appropriate. Once you go past 3 nautical miles out to 20, you add a category 1 EPIRB, that's the 406 megahertz EPIRB that we talked about already. And then once you go past 20 nautical miles out to 100, you go ahead and add your medium frequency radio. Now for the purposes of this lecture and this exam as a whole, if I say medium frequency radio or HF radio or single sideband, I'm talking about the same radio. I'm talking about a marine band, HF radio or single sideband or medium frequency radio. It's all the same wording. Now there is an exemption for vessels that are less than 50 gross registered tons that only operate less than 100 feet from land. They can apply for an exemption to not have to carry these radio systems, but again, that's an exemption they have to apply for in writing and receive approval prior to being fully exempt. The station license. The station license is associated with the ship and the ship's owners. It's good for 10 years. The owner and operator of the vessel apply to the FCC to get this station license, and it's some of the paperwork that stays on board for the duration of the 10 years. The inspection of the station. Every 5 years, pretty much associated with your Coast Guard Certificate of Inspection, a FCC licensed technician needs to come on board and inspect your radio system to ensure that it's installed properly according to the Subpart S. And they issue you, upon successful completion, they issue you that Communications Act Safety Radio Telephone Certificate. Again, some of the proper paperwork that's with your vessel. Let's take a look at the equipment itself on the ship station. The frequencies that we need to monitor for a VHF, we need channel 16, we need channel 6, and any other working frequencies. We saw that in the carriage requirements. If we have a medium frequency or HF radio or single sideband, we need to be able to copy 2182 kilohertz. Now 2182 kilohertz is the equivalent of the channel 16, but it's in the medium frequency range. So again, 2182 is the hailing and distress, the international hailing and distress in the medium frequency, just like channel 16 is the international hailing distress in the VHF band. Now there's been some update to the 2182. Actually, the Coast Guard doesn't copy that anymore. It's a recent development, but for the purposes of this lecture, this class, and the FCC testing purposes, 2182 is still a valid frequency. The power of the transmitters. Okay. Whether I have a handheld or an installed unit, low power is always going to be 1 watt. Now the high power setting is different. For portable radios, it's 5 watts, and for the fixed installed radios, it's 25 watts. That's the VHF radios. For the medium frequency radios, it's 60 watts peak to peak. So if you think of a sine wave, there's a low spot and there's a high spot. right? The peak and the valley. And between the high and low, that needs to measure 60 watts. So how do we know we're putting out any power with a single sideband radio? We talked about that high and low. Well, they have power meters on them, and you can watch when it's not putting out any signal, no transmission, your needle is going to be around 0. And when you are putting out, your full power, it's going to be about 60 watts, and the needle is going to fluctuate. When is it going to fluctuate? It's going to fluctuate when you talk into the mic. Okay, I have a single sideband radio microphone. I key the mic. When I talk into the mic, my voice then is modulated with the carrier frequency, and then there's a power out. So as the radio picks up my voice and modulates that signal, you can see the needle go from essentially 0 to full power, and it dances between the 0 and full power. It's much like if you remember, if you ever had a CB radio, when you talk into the mic, you'd watch the needles dance. Same concept here. I key the mic, I talk into it, my voice gets modulated with the carrier frequency, then there's a power out, and then I'm transmitting that signal. Now that's different from the VHF. The VHF, as soon as I push the talk button, I key the mic, I'm putting out my 25 watts if I'm on high power immediately. It doesn't matter whether I'm talking into the microphone or not. It's always continuously transmitting. Antenna patterns. So for the VHF antenna, it's a non-directional circular pattern, actually more of a donut shape. Most people think it's a dome, but it's really not. It's like a donut, and if you were to cut it in half, you would see the cross section that you see on the screen there. It's vertically polarized, which means the antenna needs to remain perpendicular to the seabed for the maximum reception, and it needs to be as efficient as practical for ground waves over the seafloor. Again, that donut shape gives us that. Now there's a difference between gain on the antennas. Most antennas, that 6 to 8 foot Shakespeare antenna, that's a 6 dB or regular gain antenna. Then you hear people talk about high gain antennas. High gain antennas are typically longer, maybe 12 to 18 feet. And what that does is it really just deforms the antenna wave. You can see the bottom graphic there, how it squashes that donut to give you a little more range. And that's what a high gain antenna does for you. It deforms the waveform to give you a maximum range, a longer range. It doesn't add any more power, but it does is it just makes that power more efficiently used for longer communications. So mounting techniques, again, we talked about it being vertically polarized, and it needs to be efficient for receiving the ground waves from the sea. So again, we want that antenna to be vertical, just like the top graphic shows. You can see on the bottom graphic, that person has that antenna raked back, and the lobes are kind of shooting up into the air and shooting down to the water. So you're not going to get your maximum distance for communications. We typically say that the VHF radio is a line of sight system, meaning it's going to be based on your antenna height and the receive antenna. So it's really a function of how high your antenna is, how high the other person's antenna is. But typically we're going to say the VHF radio is good for 20 nautical miles. Again, those waves do not bend with the curvature of the Earth significantly, so we'll say that the radio system is based on the 2 antenna heights with a maximum of 20 nautical miles. Okay, the power supply for the radio systems. Right, the power, we're talking about the DC power that's energizing these radios, needs to be able to power all the equipment associated with that radio system. For a VHF, it's real simple because everything's in one box. But for the single sideband radio, you may have multiple components. You may have a head unit and you may have a tuning unit. Both of them need power, and your power system needs to be able to supply all of the components for a particular radio system. The reserve power. You have a primary power source and you have to have a reserve power source. Now typically the way we do this for a properly installed radio system is the radio will be drawing directly off of a battery dedicated for that radio. And what will happen is the ship's system will go ahead and charge that battery. So as you can imagine, you have the power from the battery, you have the ship's power, which is recharging the battery. So you have 2 power sources there. If the ship generator, as an example, was to go down, you still have the power that's built into the battery. And that's how we do it, 2 different power supplies. That reserve power supply, you need to inspect that every 12 months, meaning that that battery that's powering that radio system, we need to inspect it every 12 months, and we can either do that by a specific gravity test or a voltage drop test. And the ship's company will do that every 12 months, and then when the FCC technician comes on board for that 5-year inspection, if it hasn't been done within 12 months, they'll do it also. The power capacity, okay. That reserve power supply needs to be able to power all the associated components for at least 3 hours. So in other words, if your generator goes down and you're just relying on that battery to power your radio systems, it needs to last for 3 hours. Now that's not 3 hours continuous transmit. You know, there's a transmit cycle, there's a receive cycle that's built into that calculation. But again, it needs to be able to do it for 3 hours. Okay, now into the operator requirements. Okay, you as the marine radio operator holding the MROP license, you need to have that original license or a photocopy on board when you're operating the vessel. So a photocopy is acceptable. We know for our Coast Guard license we need the original, but for the FCC MROP we're fine with the photocopy. Unlicensed folks may transmit under your supervision. In other words, you're the captain of the day, you got your FCC license, maybe the mate actually is on the radio, but he's under your supervision when he's transmitting. This is what a copy of the MROP license looks like. It comes from the FCC. Again, when you complete this course and pass the exam, I issue a temporary one. I then file your FCC application, and you'll receive your FCC official original FCC license in the mail. So when is an operator license not required? So if you're that voluntary vessel, that recreational boat just operating on domestic waters with a VHF radio, you don't need any kind of operator's license. Or if you're that recreational vessel and you have a fixed tune radar, again, which is kind of the same radar style that you're going to buy at West Marine, you don't need one. Also, anybody that's going to operate survival craft station or emergency positioning and getting radio beacon, the EPIRB, you don't need any kind of license. And that goes for any kind of emergency situation. It's a valid emergency situation. Anybody is authorized to use any communication systems to transmit their emergency. But again, it needs to be a valid emergency, and then you can use any means and methods available. Okay, operating procedures. We're going to take a look at the operating procedures for the ship stations. We're going to take a look at the any special procedures. Before we do so, here's what I want you to do. I want you to go ahead and watch the movie that's for the VHF radio and the digital selective calling. That's going to show us the equipment, the operation of the equipment, and the procedures. And that's going to give everybody the same baseline and understanding of the procedures and the technologies. After you watch the movie, I then want you to watch the emergency radio procedures movie. Again, it's a whole movie dedicated towards basically the Mayday call and all the other precedents of communications. That concludes the first portion of the Subpart S lesson. You've completed the first portion slides. Go ahead and watch the 2 movies, and when we come back, we're going to see the second portion of the compulsory requirements for the small passenger vessels. If you have any questions, give me a call, give me an email, and we'll get those answered promptly.